Welcome back to Low Stress Math with Mrs. Bono. We are in Unit 5, Writing Linear Functions, and this is Lesson 5, Writing Equations from a Table. Now, we've been writing an equation from 2 points using 2 different formulas. Using the slope formula, y2 minus y1 over x2 minus x1, and also using the y equals mx plus b slope-intercept form of a line. So I'd like you to stop the video and try the warm-up for Lesson 5 on page 20. And use your notes. You can do this. All right, welcome back. And here's how to do this. The first thing you do is pick 2 points. The formula that we've been using for slope. Slope, m equals y2 minus y1 over x2 minus x1. In order to do that, you need an x1 and a y1, and it doesn't matter, just pick 2 points. I am a very positive person, so I'm going to pick 2 positive points. I'll just take this one, 1, 7, and this one, 2, 9. Those will be my 2 points. 1, 7 will be my x1 and my y1, and 2, 9, well, I'm going to highlight before I start writing because you know me. As a matter of fact, I think I'll put some highlight over here too. And yeah, see, maybe some over here. We'll see what happens. All right, 2, 9. My second point is 2, 9. And that's my x2 and y2. So now, to do this, I'm going to subtract. Slope equals 9 minus 7, y2 minus y1. 9 minus 7 over x2 minus x1, 2 minus 1. 9 minus 7 is 2. 2 minus 1 is 1. That means my slope m is 2 divided by 1, 2. So I have the slope, which was the first part of the warm-up. Now I have to find the y-intercept. And I'm going to use this slope and this point to help me find the y-intercept. So I have x equals 2 and y equals 9. And m equals 2. But I don't have a b. That's what I'm looking for. B is the y-intercept that I'm looking for. So I need some kind of form. Well, I need a form Euler, but it's really just a form. So slope-intercept form is y equals mx plus b. Y here is 9 equals x is 2, m is 2. So 2 times 2 plus b. 2 times 2 is 4, so 9 equals 4 plus b. I've run out of space because I write enormous. 9 equals 4 plus b, minus 4 from both sides. 9 minus 4 is 5, so b equals 5, because 4 minus 4, of course, is 0. B equals 5. So I come over here and I put a 5 for my b. Now I have m is 2 and b is 5. So that's going to help me write my equation. Write an equation in slope-intercept form. Y equals mx plus b. Y equals mx plus b. And it's just the m and the b that I'm going to replace. M is 2, b is 5. M is 2, b is 5. And the rest of it stays exactly the same. Y equals 2, x plus 5. So this, y equals 2x plus 5, is the equation from that table. Now, it wouldn't matter what 2 points I pick. As a matter of fact, I kind of did a couple of different things. I did these 2 points. 0, 5, and 3, 11. I took this point and this point. and I did it. So 11 minus 5 is 6, 3 minus 0 is 3, 6 divided by 3 is 2. I end up with m equals 2. Then I used 0 and 5, this point here. 5 equals 2 times 0 plus b. 5 is b, because 0 plus b is 0. I could do it with any 2 points. It wouldn't matter. So when you have a chart, you get to pick what points you want to use, whatever you think is easiest. And you end up with the same equation no matter which points you pick. All right, the next one, writing equation from a table. Now it's kind of morphed into a word problem. Nelson lights a candle and records its height at various times. These are his results. Number of hours the candle is burning is X, and height of the candle in inches is Y. So before he lights the candle, it was 9 inches tall. When it was burning for 1 hour, it became 7 inches tall. 2 hours, 5 inches tall. 3 hours, 3 inches tall. 4 hours, 1 inch tall. And after that, I don't think he had much candle to burn. All right, based on the table, how tall was the candle before it started to burn? Well, that's where you're going to look at the 0 hours, 9 inches. I find it helps me a lot when I'm doing word problems to write down the units. So how tall before it started to burn? 0 hours, it was 9 inches. So before it started to burn, it was 9 inches tall. But now I got to write a sentence because, you know, English. Before it started to burn, it was 9 inches. Now, that 9 inches, that's the Y-intercept. Where something starts is the Y-intercept. If I go back to the warm-up question, my Y-intercept was 5. Remember, b equals 5? So if I come over here, oh, look at that. When x is 0, y is 5. The Y-intercept has an x of 0 and a y of 5. The Y-intercept here has an x of 0 and a y of 9. So before it started to burn, it was 9 inches tall. That's the Y-intercept. I'm going to even write that down. Y-intercept. At what rate is the candle melting, and how do we know? Rate is the same as slope. Rate of change and slope are the same thing. So write that down. Rate of change is slope. So in order to find the rate of change, I need to find the slope. And what do you need to find the slope? 2 points. Does it matter which 2 points? Not even a little bit. So I'm just going to take the first 2 points. I'm going to take this highlighted point that you know how much I love highlighted points, and I'll make that my second point, and I'll use this other one, 1, 7, because, you know, why make it difficult? So 1, 7 is 1 point I'm going to use, and 0, 9 is the second point. My slope formula, m equals y2 minus y1 over x2 minus x1. Substitute the information I know. M equals, I'm using the 9 and the 0 first. Why? Because. So 9 minus 7 over 0 minus 1. 9 minus 7 is 2. 0 minus 1 is negative 1. 2 divided by negative 1 is negative 2. My slope is m equals negative 2. Well, that's important information. At what rate is the candle melting, and how do we know? The candle is melting at 2 inches per hour. Remember, you got to keep putting the units in. When you're talking about word problems, you need units. So it's burning at 2 inches per hour. That's because there's a 1 on the bottom. You can use the word per when the denominator is a 1 because per means for 1. How can we write an equation to represent the number of hours the candle burns and the height of the candle? Well, we know 2 things that are very important. We know m equals -2, and we know b is 9 inches. So those 2 pieces of information in our formula, y equals mx plus b, you fill in m as -2 because it's burning, it's getting smaller, and b as 9. So y equals -2x plus 9. So let's check a problem just to make sure. Let's do 3. -2 times 3 is -6. -6 plus 9 is 3. The height of the candle after 3 hours is 3 inches. It worked. So you could check any point just to make sure that your equation is working. Let's keep going. Try the next page. Oh, look at this vocabulary. Ugh. Love vocabulary. Yeah, maybe if I was an English teacher, I'd love vocabulary. But remember, math is like a language. Once you know the vocabulary, you're able to do the problems. So slope is also known as rate of change. As a matter of fact, I'm even going to add the word constant rate of change because the slope on a linear equation is constant. It doesn't change. So it's known as a constant rate of change. So remember, the slope remains the same regardless of the points we choose from the table or graph. Ooh, we're going to pick points from a graph too, yeah. Independent variable, that's the x variable, or the input. Usually, the thing that you put into the equation, the x variable, is time. So time is going to be the horizontal line on a graph. It's the input, the x values, and most of the time it's going to be time. Most of the time it's going to be, that's a weird thing to say, Bono, but very often it is time. I'm going to even write that down. Very often it is time. And it's not really affected by the dependent variable. In our case, the dependent variable is the y variable, or the output. And it's called the dependent variable because it depends on what you put into the equation. So whatever it is that we're putting into the equation is going to affect the output or the dependent variable. So we'll just write that down too. Depends on what you put into the equation. So if we look back at what we were doing before, the input was the hours that the candle was burning. The output was the height of the candle. So input, independent variable. Output, dependent variable. Let's look at the next one. Lucy wants to take a bath. Well, goody for her. She turns on the water and measures the level in the bathtub because everybody does that. That's a normal thing. Nobody does that. I wish that somebody normal would write these word problems. All right, so she wants to measure the water in the bathtub at separate times. Number of minutes the water is running, x. So at 0 minutes, she has 0 water in her bathtub. That's normal. After 2 minutes, she has 3 inches of water. After 4 minutes, she has 6 inches of water, and so on and so forth. What is the independent variable? Well, let's go back and look. X is the independent variable. So let's read what it says, number of minutes the water is running. So what is the independent variable? X, the number of minutes the water is running. What's the dependent variable? Well, the dependent variable is going to be the level of the water, how much water is in the bathtub. So dependent variable, Y, the water level. I'm even going to write in inches. Because you really wouldn't measure the water in a bathtub in feet or miles. It's silly. So let's just identify that it's in inches. What is the rate of change of the water level? Rate of change, that's the slope. And how do you find slope? Y2 minus Y1 over X2 minus, you're going to need 2 points from here. So what's the rate of change of the water level? What information does this slope tell you in regards to this situation? Well, that's two different things. The first thing we're going to need to do is find out what the slope is. The second thing is explain what it means. So let's begin with finding the slope. This would be 2 points. 1 point for finding it and the other point for knowing what it means. So m equals y2 minus y1 over x2 minus x1. And I'm going to need 2 points. Let's take the first 2 points, 0, 0, and 2, 3. All right. First point, 0, 0, and the second point, 2, 3. It doesn't matter which point you pick. You'll get the same slope when you reduce this to lowest terms. So 0, 0 is going to be x1 and y1, and 2, 3 is going to be x2 and y2. So to get my slope, I'm going to do 3 minus 0 over 2 minus 0. That's why I picked the point. It's easy. And I get a slope of m equals 3 over 2. But what does that mean? That's where you go back and you put the units in. So 3 what over 2 what? Well, y is on top, so what's the unit for y? Inches. 3 inches. Over 2, the bottom is x. Minutes is x. 2 inches. 3 inches in 2 minutes. So what does that information tell you in regards to the situation? There's 3 inches of water every 2 minutes. There is 3 more inches of water every 2 minutes. Putting the units in and writing minutes correctly would help. Writing the units in really helps you explain what the slope means. If you don't have the units, you're not going to really understand what 3 over 2 means. All right, the next one. What is the Y-intercept? I know the Y-intercept. I could go back and I could do all that formula stuff, or I could just remember it's the Y value when x equals 0. What is the Y-intercept? The Y value when x equals 0. So I have that point, 0, 0. The Y value here is 0. So I get B equals 0. And again, I'm going to put the unit in with it. I'm looking for the Y, which is inches. So B equals 0 inches. And what does that mean in this situation? It means there was no water in the bathtub when she started. The Y-intercept tells us There are 0 inches of water in the bathtub when she starts. Write an equation in slope-intercept form representing the number of minutes the water runs and the water level. All right, so in order to do that, I need two things. I need the b, which is 0, and the m, which is 3/2. So y equals mx plus b, m the slope, b the y-intercept. And once I fill those two things in, I'll have a nice little equation that I can check and make sure it's the correct equation. So y equals 3/2x plus 0. Wait a second. Do I have to add the 0? Is that something that's really important in this equation? No. If I don't write that, as a matter of fact, just write 3/2x. Y equals 3/2x. So let's test this. 3/2 times 8. Well, 3 times 8 is 24. 24 divided by 2 is 12. Hey, it worked. I got 12 inches of water. Okay, not too bad. Your job, should you choose to accept it, is to do the last problem on your own. I'll talk to you soon. Take care.